Welcome to How to Succeed in ECE Without Really Trying. I'm Dr. Linda DeBrunner, and in this short video, I'm going to introduce the concept of phasors. Some people refer to phasors as a transform, but it's really just a shorthand way of writing our math. So we can define a phasor of a sinusoidal waveform to be V of j omega equal to A e to the j phi, where A is the amplitude of the cosine waveform and phi is the phase angle of that waveform. Omega is typically a constant and is always the same for a given power system. We then can write this definition using a shorthand notation often called polar form or phasor form, where we just write A is the magnitude and then a symbol for angle and then provide the angle, in this case, phi. These are related to S. So that phasor is going to be the voltage at a specific frequency, omega. And for example, the wall power supply in the US is 60 hertz waveform, and so omega will be equal to 2 pi f, which will be 377 radians per second. We can similarly write a current phasor in the same way, and it would be called I of j omega. So we can also talk about VRMS values. So VRMS of j omega will be A over the square root of 2 at an angle of phi. And IRMS j omega will be A over R times the square root of 2 at an angle of phi. So all we do to get from the voltage, which is RMS, to the current in RMS is divide by the resistance R. Almost always we will drop the variable omega from this notation because in power systems omega is a constant. The frequency omega is known a priori and it cannot change.